Okay, so you hear these terms thrown around all the time, right? Neural networks, LLMs, AI. It can get pretty confusing. But what's the actual difference between a neural network and a large language model? Well, it's honestly way simpler than it sounds, and we're going to break it all down for you right now. So, to really get a handle on this, we've got to start at the beginning with the core concept that everything else is built on top of. And that, right there, is the neural network. You can think of it as the foundation, the bedrock of almost all modern AI. So let's get a really clear picture of what we're talking about. Okay, so what is it? A neural network is basically a computer system that's inspired by, well, the human brain. It's made up of all these little interconnected digital neurons, or nodes. And just like in our brains, they pass signals to each other. It's a really cool way of programming a computer to mimic how we think. And its main job, it's actually pretty straightforward. Its whole purpose is to learn how to spot patterns in data. Seriously, that's it. So whether it's figuring out if a picture is of a cat or a dog, or trying to predict stock prices, at the end of the day, it's just looking for patterns. All right, so now let's talk about the big new thing on the block, the LLM, or large language model. You've definitely used these, or at least heard of them. We're talking about things like ChatGPT or Gemini. Let's see how they fit into this picture. And here's the most important thing to get right off the bat. An LLM isn't some totally different technology. It is a neural network. It's just a very, very specific kind of neural network. And its one big specialty, its whole job is to understand and generate human-like language. This quote from IBM really nails it. It says LLMs are basically giant statistical prediction machines. So when you ask it a question and it gives you an answer, it's not really thinking like we do. What it's actually doing is making a super educated guess about which word should come next, the next, the next, all based on the patterns it learned from, reading practically the entire internet. Okay, so we've got neural networks on one hand and LLMs on the other. So how do they relate? Let's make that connection super clear. Right, this is the key. A large language model is a type of neural network. That's it. It's the family it belongs to. Think of it like this. All squares are rectangles, right? But not all rectangles are squares. It's the exact same idea here. All LLMs are neural networks, but not all neural networks are LLM. So then, what makes an LLM feel so different, so much more powerful? It really just boils down to it being massively bigger and way more specialized. We're talking about a system that is just huge compared to most other neural networks. And when I say bigger, I mean the difference in scale is just mind-boggling. A typical neural network might have thousands, maybe millions of parameters. You can think of those like little dials it turns to learn things. But an LLM, we're talking billions or even trillions of them. It's not just a little bigger, it's a whole different universe. It's like comparing a bicycle to a rocket ship, for real. Okay, so we've established that an LLM is just a giant, super specialized neural network. So let's break down the three core differences that really set them apart. This chart lays it out perfectly. First up is scale. As we said, NNs can be any size, but LLMs are always massive. Next, data. A regular NN is usually a specialist. You train it on specific stuff, like just images or just numbers. But an LLM is a total generalist. It's trained on this huge, diverse ocean of text and code from all over the internet. And that leads to the third thing, purpose. Your typical NN is built to do one specific job, like classifying images. An LLM, though, it's designed to be a jack of all trades for anything involving language, writing, summarizing, chatting, you name it. You know what? To make this really stick, let's use a simple analogy that you can share with pretty much anyone. So think of a regular neural network like a specialist librarian. This person is an absolute world expert, but only on, say, ancient Roman history. They can answer any question about that one topic with incredible detail. Now, the LLM isn't just one librarian, it's the entire national library. It's read every single book on every single subject, and it can see how ideas from Roman history might connect to modern engineering or even poetry. All right, let's wrap this up. If you only remember a few things from this whole explainer, let it be these key points. Okay, here's your 30-second summary. First, all LLMs are neural networks, but not all NNs are LLMs. Easy enough? Second, a neural network is just the basic idea of a computer system that learns patterns. Third, an LLM is a giant version of that, specialized just for language. And finally, the big three differences are scale, data, and purpose. That's it. So now you know the what. But what about the why? Why does this difference even matter? As we move forward and AI gets woven into everything we do, it really makes you wonder, what's going to be more important? The deep, focused expertise of a specialist neural network, or the broad, world-connecting knowledge of a large language model? The answer to that is probably going to define a lot about our future.